Hi, this is Michael Cohn of Advanced Tubular Technologies. You're looking at our VTube-STEP software that imports data from solid modeling geometry files in the STEP format and allows you to measure the tube virtually and then come to a set of master coordinates and bend data to be used in your bending process. What I'd like to concentrate on today is how to perform extensions to the ends of the center lines using end trim surfaces and points. You can see we have a model on the screen that has more than just tubing, and so what we want to do first is we want to perform a collection of the cylinders that represent the center line of the tube. Now you can see that we've selected straight segments on the outer diameter. What I'd like to do in order to allow the program to automatically calculate the wall thickness is to also select an inner diameter. We'll do that on the first straight, like this. So now we have an outer diameter and an inner diameter, and the software will automatically calculate the wall thickness for us. Now at this point we can perform a calculation in order to generate the center line of the tube. And we have tube model geometry superimposed on the original model. Over here we have XYZ data and we have bender data as well. I'm going to go ahead and orbit and zoom in on one of the ends. You can see here that we have the endpoint of the tube inside this external piece of geometry on the tube. What I'm going to do is I'm going to tell the endpoint that it needs to extend out to the center of this surface. In order to do that, we need to do some more collection like this. End trim from surface, and this is segment 7. So now we have a trim surface number 7. Let's perform another calculation. And of course the endpoint is extended out to inline with the centroid, which is the red point here, of this surface geometry. Any surface geometry can be selected. It doesn't have to be just a surface like this. It can be any shape, and the centroid will then be used to perform the trim. Now let's say that this is not precisely the endpoint of the tube, but it's somewhere else relative to the surface of the end of this geometry. We allow for offsetting the endpoint. First I'm going to increase the transparency of the original model. And now I'm going to change the end B trim offset. Let's say that it's -10 millimeters from the surface back in this direction. We perform another calculation by regenerating the tube model. And you can see that the endpoint has now been moved 10 millimeters behind this surface. With this feature you can of course get very precise control over where the endpoints are located.